Hi everyone. Today we are diving into a topic that I believe is critical for any growing engineering organization: driving engineering standards across teams. From my extensive experience working with various teams at scale, I have observed a recurring pattern. Most engineering teams don't falter because of a lack of talent or brilliant individual engineers. Instead, their biggest challenge often stems from a lack of consistent standards. Think about it. I have witnessed scenarios where one team consistently ships clean, production ready code, while another, perhaps just down the hall, struggles with unstable deployments, constant bugs, and a never ending cycle of firefighting. And then there's the team that builds complex systems that no one else can understand or maintain. Over time, this inconsistency inevitably breeds chaos. It leads to agonizingly slow release cycles, unpredictable system behavior, and perhaps most damagingly, deeply frustrated engineers. The fundamental difference I have found isn't talent, it's the presence or absence of well defined and consistently applied standards. In this video, I am going to share how you can effectively drive engineering standards across your teams backed by real world examples that have proven to be incredibly successful. So, what exactly do we mean by engineering standards? It's much more than just coding style or formatting rules. Engineering standards are the foundational principles and practices that define how your organization designs, develops, and delivers software. This encompasses a wide array of areas, including how you write and structure your code, your pull request workflows, your testing methodologies, continuous integration and continuous deployment pipelines, architectural patterns, security protocols, and even versioning strategies. These standards create a unified approach to software development. But here's the crucial insight, and it's often misunderstood. Standards are not about control. They are not about stifling creativity or imposing rigid rules for the sake of it. Instead, their primary purpose is to reduce cognitive load for your engineers and paradoxically enable greater speed and agility. When engineers don't have to constantly make decisions about basic operational aspects, they can focus their mental energy on solving complex business problems. For instance, a simple yet highly effective standard we introduced in one team was a clear branch naming convention, such as feature forward stroke engineer's initial forward stroke ticket hyphen purpose. So, an example might be feach forward stroke HP forward stroke 1234 add login endpoint. This seemingly small change had a massive impact. It dramatically improved traceability, making it easier to track changes and understand context. It simplified debugging as the branch name immediately provided clues about the feature or fix. And it fostered better collaboration as everyone understood the purpose of each branch at a glance. Good standards ultimately remove ambiguity and streamline processes. Now, let's address a common challenge. Why do most attempts at implementing engineering standards fail? The typical approach I've observed in many organizations is to try and enforce standards purely through documentation. Teams will write extensive Confluence pages, send out company wide emails detailing new rules, or publish lengthy policy documents. And what's the result? Often nothing changes. The new standards are ignored and old habits persist. Why does this happen? The fundamental reason is that engineers don't primarily follow documents, they follow systems and workflows. I learned this lesson firsthand. We had meticulously crafted PR review guidelines outlining exactly what constituted a good review, but adoption remained low. It was only when we embedded these guidelines directly into the workflow itself, perhaps through automated checks, required fields, or integrated tooling, that we saw a significant improvement in adoption and consequently code quality. If a standard isn't integrated into the daily tools and processes engineers use, it's likely to be overlooked. To truly drive standards, you need a comprehensive approach. I have identified 6 key pillars that, when addressed systematically, can transform your engineering culture. Let's explore each with real examples. Code standards is often the first thing people think of. We standardized elements like branch naming, linting rules, and code formatting. But the key here was automation. We didn't just document these standards, we automated their enforcement through pre-commit hooks, continuous integration checks, and integrated development environment or IDE configurations. Manual standards simply don't scale. Automation ensures consistency without relying on individual memory or discipline. Beyond just reviewing code, we focused on standardizing the PR review process itself. This included mandatory PR descriptions and templates that clearly articulated the changes and their impact, automatic linking of PRs to their corresponding tickets in our project management system, and defining required reviewers based on code ownership or expertise. Crucially, we emphasize that PR reviews are not merely approvals, they are vital knowledge sharing systems, because the PR review meetings are a golden opportunity for junior engineers to ask clarifying questions and grow from the experience of senior engineers. This shift in mindset significantly improved code quality, accelerated onboarding for new team members, and fostered better cross team alignment as knowledge was actively disseminated. Handling sensitive data like API keys or database credentials is a common pain point. We standardized secret handling using tools like JITcrypt. This ensured the encryption of sensitive data within our repositories, controlled access only to authorized personnel, and eliminate the dangerous practice of committing plain text secrets. As a result, security became a consistent integrated practice across all teams, significantly reducing our attack surface. Standards without enforcement are often ineffective. For testing, we defined minimum unit test coverage thresholds and enforced these directly within our continuous integration pipelines. If a PR dropped below the required coverage, it couldn't be merged. This led to a dramatic reduction in production issues and instilled higher confidence in our deployments. It reinforced the idea that quality is a shared responsibility and standards are there to support it. To move beyond reactive coding, we introduced a standard requiring design documents for all major architectural changes. Each document had to include a clear problem definition, a proposed solution, an analysis of trade offs, and considerations for scalability and maintainability. This practice transformed teams from simply writing code to engaging in intentional system design, leading to more robust, scalable, and well thought out solutions. Finally, we standardized semantic versioning, major, minor, patch. We clearly defined what each component meant: major for breaking changes, minor for new features that are backward compatible, and patch for backward compatible bug fixes. This became an invaluable communication contract between teams, allowing them to understand the impact of dependencies at a glance. We integrated this with our CI/CD pipelines, enabling automated tagging and release notes, which in turn ensured predictable releases, safer upgrades, and much better coordination across the entire engineering organization. Implementing standards is one thing, ensuring their widespread adoption is another. Here are 4 strategies that proved highly effective. 1. Don't make engineers seek out standards, make them the default. Enforce them through templates for new projects, integrate them directly into your CI pipelines, and bake them into your tooling. When the easiest path is the compliant path, adoption naturally follows. 2. Build pre-configured golden paths for common tasks. This could be repository templates, standardized CI/CD pipelines, pre-configured testing frameworks, or automated versioning setups. Make the right path the easiest path, and engineers will naturally gravitate towards it. 3. Work collaboratively with your tech leads and senior engineers. Build alignment and consensus around the standards rather than simply dictating them from above. When the team understands the why behind a standard, they are much more likely to embrace it. 4. Finally, track the impact of your standards. Measure metrics like deployment speed, incident reduction, and onboarding time. Standards should evolve based on data, not just intuition. If a standard isn't delivering the expected benefits, be prepared to adapt or discard it. In conclusion, driving engineering standards is not about exerting control or creating unnecessary bureaucracy. It's about building a robust system where teams can move faster, systems are more reliable, and engineers can collaborate effectively. From my experience, even simple standards like a consistent branch naming convention or semantic versioning can create a massive positive impact. Because at scale, consistency is the key ingredient that turns good engineering teams into truly great engineering organizations. If you love this content, please like, comment, share and subscribe for similar content in the future. See you in another video. Until then, elevate.